position here at 1 instead of 0, and then we could just use the accumulator of 0 to say the position of the smallest item or the smallest distance before index 1 is literally 0. There's only one item I'm considering. That is clearly going to be the smallest if that's the only item I'm considering, if that's the only distance I'm considering. And what's its position? Its position is 0, right? So that's a convenient way to do this so that you could still preserve the relationship that the accumulator is always the position of the minimum if you're only considering the items before or only considering the distances before the given index. Okay, so the end range, that's going to be where we're going to end it. That's going to be the same. Again, you could use weights.length, heights.length, genders.length. We want to go through the whole array. So I'll just do heights.length here. Okay, so notice here I put my accumulator to make sure you know what this is. Again, the accumulator is not the current minimum, it's the current index of the minimum. Okay, so when I do the comparison, when I want to update my accumulator, what I'm going to be saying is my current minimum is at current closest index. So if I want to see whether I'm going to take this new item, if this new item is smaller, I am going to be taking the item that's at current closest index rather than current closest index itself. So maybe just to give an example here, I think, again, this is why drawing the table is helpful here. So if I have an array of distances that's, let's say, 5, 2, or let's make this maybe 5, 7, and then let's make this 4, and 8, and 3, right? This is what my table would look like. So we have our ACC, we have our item. So remember, our ACC is starting at 0, and our item is starting at 1. And again, I'll just use ACC is our current closest index. And our item is just going to be the given index, right? So that's the position that we want to look at next. Right, so right now our index here, notice we say the closest index is 0 and our item is 1. This means we've looked at all of the items before index 1, so we've just looked at this 5, right? Okay, now we want to get our new accumulator, right? And so item is going to go up to 2, right? And I'll just draw these first few. 3, 4, and 5, right? So first we're looking at the item at index 1, right? So we're looking specifically at distance array of 1, right? Because this is what we want to get the minimum of. We want to get the minimum distance. So distance array of 1 in this example, right? So I'll just say this is distance array, is going to be 7. So when we do the 7, do we want to compare the 7 to the 0? No, we want to compare the 7 to the thing that's at position 0. So we want to ask, is distance array 1 less than distance array of 0, right? That's the question we want to ask here. And so we're asking, is the 7 less than the 5? And it's not, right? So we're saying, okay, then the minimum is still at position 0. Now again, we don't want to update the accumulator. We don't want to say it's 5. We want to say that we just want to keep track of the position, because at the end, remember, we're going to need the position of the minimum distance so that we could get the corresponding gender, right? If we just have the minimum distance is, let's say, 3, that doesn't help us, right? Because then we would say, okay, that weight height pair that's a distance 3 away, which person is that, right? What's their gender, right? But if we have the position of that, then we could say, okay, we could get the corresponding gender from the genders array. Okay, so now we keep the accumulator as 0 and we compare the item at 0 to 2. So now we ask, is distance array of 0, right, or sorry, is distance array of 2 less than distance array of 0? And here we see, okay, the 4 is less than the 5. So what do we want to keep here? We don't want the 4 because, again, we want the position. So the new accumulator becomes 2, right? Because we want the position of that 5, right? And so now the next thing we would ask is distance array of 3, right? That's the index here. Is that less than distance array of 2? And we would say, okay, distance array of 3 is going to be that 8. Is that 8 less than the current minimum of 4? And the answer is no. So we keep the accumulator as 2. Right? And finally, we compare the item at 4, and we ask if it's less than distance array of 2, and it is, right? Because the one at one at position 4, 0, 1, 2, 3, 4, that last one, 3 is less than 4, right? So our final accumulator, I didn't want this last row here, our final accumulator would be not the 3, but the position of the 3. So 0, 1, 2, 3, 4, it would be the item itself. Right? So again, once you have this table, it makes it easy to figure out what you put here. So again, we take the starting accumulator was the 0, right? That's the first row, first column. Remember, that we're saying is the position of the smallest distance before index, right? And this is why we start at index of 1, right, and not 0. The number that we're using as the first number of range is the first row, second column, right? And again, we're going to all the way up to heights.length. You could see here that we had five entries in the distance array, which would also be the number of entries or the number of items in the heights array, right? So we went up to 4. We wanted to go through all the items. So that would be positions 0 through 4. And remember, range again takes one more than whatever you want to stop it at. So you would stop it, you would put 5 here, which would be the length of weights, would be the length of the weights array, or the length of the heights array, or the length of the genders array. Okay, so that tells you what to put for your starting accumulator, your starting item, and your ending item for the array here, or it tells you what to put as the second input to range. And now we want to see, how do we get from one row, one accumulator, to the next? Well, in each case, what we're doing to determine what the next accumulator is we're saying, is the distance at that current closest index, right? So is the distance at current closest index, is that less than the distance at the current item or index? Right? So we would ask, this should be distance array. So we would ask if that's less than distance array of index. And if it is, what did we want to do? So when distance array, I could put answers to these, right? This was no. This was yes. This was no. And this was yes, right? So whenever the answer was no, we saw that we kept the current accumulator. We kept the current closest index, which is why if the answer to this question is no, right, we just return the current closest index. But if it's yes, what did we wind up doing? We took the item or the index, and that became our new accumulator. So over here we took the 2, that became our new accumulator. The 4, that became our new accumulator. So in general, our new accumulator is literally just going to be the item or the index. So here we'll just return index. Okay, so this will give us the index of the closest item, of the closest weight height pair. And remember what we said is then we want to get that person's gender. So now that we have the position in the array that we want, we return genders of that index with the closest distance to the point, that weight height point that we are considering. So we'll just return genders index of closest. Okay, so that should do it. Let me just close this comment here, and we could run it to see if that works. Right, so we see male, male, female, female. So 140/60 was should log female. We got the exact opposite here. Oh, sorry. So we wanted to reverse this here. That's why. So again, what we did is we asked if the distance array of index is less than the distance array of current closest index, we would return index. So let me just swap that here. This is why it's important to test your code. Right. Okay, so we do that again, and now we get female, female, male, male. Okay, so that was the right answer. And remember I just said we were just curious what would be the gender, or I was curious, I guess, because I was saying this to you. Maybe you don't care at all, but I'll just point this out. We said what was the gender of someone who was going to be 200 pounds and 65 as the height. So let's see what that winded up being. Okay, so that person winded up being female. So the graph that I showed before, 265, I apparently wasn't right with looking at this graph. The middle was somewhere closer to the female. Maybe it is actually that female. And so that would be your answer. But if I maybe raise that to 67, we would get male, right? So the difference of a couple of inches mattered on whether it predicted male or female. Okay, so this is how you solve the problem, and hopefully this helps you solve problem 10 on the actual exam.